Hello grade 10 students. Today I am here to teach you chapter 31 in your textbook that's called Angles in a Circle. So this is another important geometry lesson. First we'll look at some of the terms that we need to identify in this unit. When you take a circle, this is called the center. So this point is the center. So here, when you take this length, what you call that? So that's less than half of a circle. So we call this is minor arc. Then what about the other part? The remaining part we say that's the major arc. Now we need to identify what is this angle. Now with this arc, this is the center, joining these radius, you get this angle. So what you call this angle? So we call the angle subtended by the minor arc AB at the center. So it's really important to identify the angle. So this means this is the center joining the 2 points on the arc with that we call those are radius. So when you combine those two, you get this angle. So what is this angle? AOB. So we need to identify what is AOB. So we'll write down what is AOB. AOB is the angle subtended by the minor arc. This is the minor arc. Subtended by the minor arc AB at the center. Then what about this diagram? This is the other part. So this is the major arc. So this part is the major arc. So what you call this angle? So this is also AOB. But we can write this is AOB reflex angle. Because reflex means more than 180 and less than 360. So this is a reflex angle. So we have to say this is also angle subtended by the major arc. This is major arc. So we'll write down this is for this one. And I'll write here this means AOB reflex angle is the angle subtended by the major arc also AB. Major arc AB at the center. Then what you call this one? This is the minor arc. But this angle is other side, on the other side. So we call that's the remaining part of the circle. So we write down angle subtended. So this what you call this one? ACB. Not at the center here because center is here. This one is the center. Angle subtended by the This is about minor arc. ACB is the angle subtended by the minor arc AB on the remaining part of the circle. On the remaining part. Remaining part of the circle. Now, what about this one? This one, this is the major arc. When you take major arc, this is on the other side, the remaining part. So, this is also same as before, but only difference is about the arc. This one is in major, this one is in minor arc, and the other one is in the major arc. So, how can you write down this angle? This is ACB is the angle subtended by the major arc AB on the remaining part of the circle. So, you need to identify this angle. This is the angle at the center. This is on the circle. Now, we'll take these diagrams and identify what are these angles. What is X? Can you identify X angle? X is this is minor arc, angle subtended by the which arc? By the minor arc, because this is the minor arc. Minor arc AB at the center. Then what about Y? What can you write about Y? Now you have to think about Y is this arc. So I'll take another color. I'll take red color. This one is another arc. So this is the angle subtended at the center. So how can you write down Y? Y is the, right here, Y is the angle subtended by the minor arc BC now. By the minor arc BC at the center. Now, if I ask you what is this whole angle? AOC angle. And I can write here X as what? X as AOB angle. Another way of writing angles, AOB angle. Y is BOC angle. Then what about X plus Y? How can we write X plus Y? X plus Y is the angle subtended by the minor arc AC at the center. So I'll write down here again X plus Y. I'll write down here X plus Y is the, or I can write x plus y is same as AOC angle. AOC angle, that's the angle subtended by the minor arc AC at the center. Now take this diagram. Identify what is A and B. Try to write down first. What's the angle? So the angle is, if I say what is A? A is the angle subtended by the minor arc AB on the remaining part of the circle. So you need to identify, not at the center now. So what is A? Angle subtended by the minor arc AB. AB is the arc now, minor arc AB on the remaining part, of the circle. Then what is B? B also same thing, only difference is the letters. When you are writing the angle with letters, A is APB and B means AQB. But same thing, same minor arc on the remaining part of the circle. So same thing you can write down here. Angle subtended by the minor arc AB on the remaining part of the circle. Now try to identify this one. X and Y. Now this is the center. So this is the angle at the center with this minor arc. So if we label this is AB, this is C, we can write X is AOB angle, or same thing we can write angle subtended by the minor arc AB at the center. Then what is Y? Y is ACB, ACB. What's that? The angle subtended by the minor arc AB on the remaining part of the circle. Now we'll see this one, this diagram. This one, identify X, Y. What's X? X is A, I'll put a letter here, P. X is A, P, B. A, P, B. So, how you write down? Angle subtended by the minor arc AB on the remaining part of the circle. Then what is y? Y means BPC angle. BPC angle. That's also same thing. What's the difference? Now this is minor arc BC, not AB. So same thing you are getting, but different arc. So I can write down this one. BPC angle is same as y is the angle subtended by the minor arc. What's the arc now? Minor arc BC on the remaining part of the circle. On the remaining part of the circle. Now, if I ask you what is x plus y, identify x plus y is with the AC arc. So you have to say angle subtended by the minor arc AC on the remaining part of the circle. Now here I have drawn several angles. Now here this one is the angle at the center. So because it's these two lines attached to the center. So angle subtended at the center by the minor arc. What about these angles? All these other angles. Here, all these other angles. These angles are the angles subtended by the minor arc on the remaining part of the circle. Then here, this one, both are given. This is the angle subtended at the center. This is the angle subtended on the remaining part of the circle. So we are trying to find out a relationship between these angles in this lesson. We'll look at example 1. The center of the circle in the given figure is O. Write down the angle that is subtended by the minor arc PR. So identify PR is this one, minor arc PR, on the remaining part of the circle. So which one is that? PCR. PCR angle is that. Then the second part, the angle that is subtended at the center by the minor arc PR. So this is the minor arc. Which angle subtended at the center? This one. So I'll mark this is the previous one. And here, what's the angle? POR. Now look at the next one. Write down the angle that is subtended by the major arc PR. Now I'll take a different color and show you which one is major arc PR means this one. This arc. The angle that is subtended by the major arc PR on the remaining part of the circle. So on the remaining part means opposite side. So which angle is that? This angle. So PQR. Other part, the angle that is subtended at the center by the major arc PR. So this is the major one. So which one subtended at the center? This one. So how can we write down this one? POR. But you have to write down reflex angle. POR. POR. Reflex angle. Exercise 31.1. Copy the 4 circles in the figure given below onto your exercise book. The center of each circle is denoted by O. So, these are the centers. Mark each of the angles indicated below. First one, it says an angle that is subtended on the remaining part of the circle by the minor arc in figure A. So, this is figure A. Which one is minor arc? This is minor arc. But we want the angle subtended on the remaining part. So, which one is remaining? The opposite part. So, we can mark any point P and then mark this angle. This angle is the angle subtended on the remaining part of the circle by the minor arc AB. So, how can we write down this angle? APB. Look at the next one. The angle subtended at the center by the minor arc in the figure B. So, minor arc is this. Angle subtended at the center. So, this one. So, this angle is the angle subtended at the center. So, we can write AOB. Third one. An angle that is subtended on the remaining part of the circle by the major arc in figure C. So, which one is major arc? This part is the major arc. We want angle subtended on the remaining part. Remaining part is this one. So, we can take any point P and this angle is the angle on the remaining part. So, we can write APB. Next one, the angle subtended at the center by the major arc in figure D. So, major arc is this one. Subtended at the center means this angle. How can we write down that angle? AOB reflex angle, because this is a reflex angle. Question number 2. According to the figure, write down for the minor arc AB. So, where's minor arc AB? Identify first. This one. The angle subtended on the remaining part of the circle. On the remaining part of the circle means opposite to that. So, this angle they want. So, we have to write down the angle. So, how can you write down? AYB. AYB angle. Then the next one, the angle subtended at the center. So, this is the minor arc. Angle subtended at the center means this one. AOB angle. Next one, write down for the major arc AB. I'll take a different color now. Major arc means this one. This is major arc. Angle subtended on the remaining part of the circle. Remaining part. So, this is the major arc. Remaining part is this. So, this angle we are talking about. So, what's the angle? AXB. Next one, the angle subtended at the center. So, we are considering the major arc now. What's the angle subtended at the center? This angle. AOB reflex angle. Question number 3. The center of the circle in the given figure is O. The point X is on the major arc PQ. So, here this is minor arc, major arc is this. So, X is on the major arc. Write down the angle that is subtended on the remaining part of the circle by the minor arc PQ. So, minor arc identify, and we want the angle on the remaining part of the minor arc. So, what's the remaining part? This one. So, this angle is the angle they want. So, what's the angle? PXQ. Write down the angle that is subtended at the center by the minor arc PQ. Minor arc PQ is this. So, angle subtended at the center. So, they are talking about this angle. POQ angle. Mark any point on the minor arc PQ. Minor arc is this PQ. And name it Y. Define the angle PYQ. Mark any point on the minor arc. So, I'll mark it the different color. Okay, so here this point is Y on the minor arc. Then define the angle PYQ. PYQ angle, this angle. How can we define? This is, if you take the major arc, this is the remaining part of the circle. So, how can we write down PYQ? Angle subtended. So, this is opposite is a major arc subtended by the major arc. Which arc? Major arc PQ on the remaining part of the circle. Next one, fourth one. Write down the angle that is subtended at the center of the circle by the major arc PQ. Now, PQ major arc is this. Which one is the angle subtended at the center? This one. So, write down the angle. So, which angle is that? POQ. But this is the reflex angle. So, you have to write down reflex angle. Question number 4. The center of the circle in the figure is O. Name an angle that is subtended on the remaining part of the circle by the minor arc AC. Now first you need to identify the minor arc. This is the minor arc AC. Angle subtended on the remaining part. That means on the other side and here part of the circle. So this side, which angle is that? This is the angle. So ADC angle. Next one, write down the angle that is subtended at the center by the minor arc AC. AC is the minor arc here. Angle at the center is this one, AOC. Next one, write down an angle that is subtended on the remaining part of the circle by the major arc AC. So, which one is major arc? Major arc is this. So, we want the angle subtended on the remaining part. Remaining part means opposite side of the circle by the major arc AC. So, which one is opposite side? This angle, ABC angle. Write down the angle that is subtended at the center by the major arc AC. So, major arc, the angle subtended at the center is this one, AOC angle, but that's a reflex angle. Question number 5. The center of the circle in the figure is O. Write down for the minor arc AB. So identify the minor arc. This is the minor arc. The angle subtended on the remaining part of the circle. Subtended on the remaining part means opposite side. So to this one, that's this angle. ACB angle. Next one, the angle subtended at the center. So to this one, angle subtended at the center is this one, AOB. Next one, now you have to take the minor arc BC. So I'll take another color now. BC is this one. The angle subtended on the remaining part of the circle. So remaining part means opposite to that. So which one with these two letters? This is the angle. So CAB angle. Next one. The angle subtended at the center. So we are talking about this BC. With BC, what's the angle at the center? This one, COB. Now we are trying to find out a relationship between angles. Angles subtended at the center and angle subtended on the other part of the remaining part of the circle. Now look at this diagram. So this is center, we'll take center O, and this is given 40 and this is given 30. Now what do you know about circles? When you take the center and this one, this is the radius. PO, OA, OB are radii of the circle. So what can you say about the radii? All are equal. So we can say this is equal to this one and this is equal to this one. Now look at the triangle. This triangle is a isosceles triangle. Two sides are equal. So first you can write AO is equal to OB is equal to OP. All are radii of the circle. And this is given 40. So we can write APO is an isosceles triangle. So if this is 40, what can you say about this angle? This is also 40. In an isosceles triangle, the angles, corresponding angles to the equal sides are equal. So we can write this is 40. So what can you say about this angle? Look at carefully. APO. When you extend PO line, you get this angle. What do you call that? That's the exterior angle. So AO, we'll say this is Q. AOQ angle is what? AOQ angle is the sum of these two angles. Exterior angle is equal to sum of opposite interior angles. So we can write this one as 40 plus 30. So what's the value? 70 is this one. Then we can do the same thing for the other side. You get an isosceles triangle. If this is 30, this is also 30. Then 30 and 30 becomes here 30 plus 30. You get 60. So I can write BOQ angle is 30 plus 30. That's 60 degrees. These are all because of exterior angle. Then what can you say about AOB angle? What's AOB? This full thing. 70 plus 60. So I can write AOB angle is 70 plus 60. That's 130. What about APB angle? APB angle is 40 plus 30. Here we made a big mistake. What's the value here? 40 plus 40 is 80. All these 8, this is 80. 40 plus 40, this becomes 80. 80 plus 60, you get 140. And this one, 40, 30, 30, 60. Other side is okay. So APB angle is 40 plus 30 is 70. What can you say about these two angles? Angle subtended at the center. An angle subtended on the remaining part of the circle with the same arc. 70 and 140, this is double. So we can say the angle subtended at the center, AOB angle, is twice of APB angle. Angle subtended on the remaining part of the circle. So we'll take another example and identify this. Take this example. Which one is angle subtended at the center? So angle subtended at the center is this one. And angle subtended on the remaining part of the circle is this one. So we are trying to find out a relationship between these two. So what we can do, we can draw a line and extend it to up to Q. We know, again, these two, all these lengths are equal because all are radii. This is an isosceles triangle. This is 20. This is 20. And this is 50, this is 50. Then again we can write 50 plus 50 is 100 here. 20 plus 20, you get 40 here. Then what can you say about APB angle? APB, that means the whole thing. 50 plus 20. What's the value? You get 70 degrees. Now think about AOB angle. AOB angle is 100 plus 40. So you get 140. Now look at the relationship. What can you say? 70 and 140? 70 times 2. So we can write AOB angle is equal to twice of APB angle. Twice of APB angle. Now look at this one. Again you have given this is 40. This is 35. So we'll draw a line and extend this to Q. Same theory. These all are equal because of radii. This is 40, this is 40 because of isosceles triangle. This is 35, this is 35 because these are isosceles triangle. Now 40 and 40, here this angle becomes 80. Exterior angle is equal to the sum of opposite interior angles. What about this one? 35 and 35, you get 70. Again, same thing. Exterior angle is equal to the sum of opposite interior angles. Then, what can you say about AOB angle? Is 80 plus 70. That's 150 degrees. Then what about APB angle? APB angle is 40 plus 35. So what's that? 75. Look at these two. 75 times 2 is 150. So we can write AOB angle is twice of APB angle. So we took 3 examples to see what type of relationship is there with these angles. Now we'll take this as a theorem. Now we'll take a general one. So without giving numbers, we can take x and y. Now what happens? This is general case. This is the angle subtended at the center, and this is the angle subtended on the remaining part of the circle. AO is same as OB is same as OP. What's the reason? All these are radii of the circle. Then if this is x, this is also x. If this is y, this is y. Why? Because of isosceles triangle. We can write APO triangle is an isosceles triangle. Then what can you say about, we'll take this one Q, AOQ. AOQ is same as x and x plus x. What's the reason? Sum of the interior angles equals to the exterior angle. So we can write this is because of exterior angle. Then you get 2x. So this is 2x. Then what about QOB angle? Y plus y. That's also same reason. Exterior angle is equal to the sum of opposite interior angles. That's 2y. Then what can you say about the full thing? AOB angle. We can say AOB angle is 2x plus 2y. I can take 2 out from both of these terms, x plus y. What is x plus y? X plus y is which angle? APB angle. So I can write AOB angle is twice of APB angle. So when you take general value also, you get a relationship. The angle subtended at the center is twice as the angle subtended on the remaining part of the circle. So we'll take that one as a theorem. So theorem number 1 is the angle subtended by an arc. We'll take AB by an arc at the center. So this angle is twice the angle subtended by the same arc on the remaining part of the circle. So same arc on the remaining part of the circle is this one. I'll take P. So this one, if I take this one as O, AOB angle is twice of 2 times APB angle. So we'll try to prove this. So what you know? AB, P points on the circle. ABP points on the circle, and we know O is the center of the circle. So what you need to prove? To be proved, AOB is twice of APB angle. So we need a construction. So what you need? We need to draw PO line and extend to Q. Draw PO line and extend to Q point. Then we can start to prove that. So what is the first thing we can say? All these lengths are equal. AO, BO, PO, all are equal because of radii of a circle. Then when you take POA or APO triangle is an isosceles triangle, so this is equal to this one. So I can write APO is an isosceles triangle. So APO angle, this angle is equal to this angle. APAO angle. APO angle is equal to OAP because of isosceles triangle. Then what is this one? This one. So we'll put X here. X. This is X. Then you get AOQ angle is this plus this. So APO angle plus OAP angle, that is 2x. Same angle. Then again you can write the same thing for the other triangle. What is the other angle? Except A, we can put B. Same thing with B. BPO triangle is an isosceles triangle. So that's Y equals. We'll put Y here. This is Y. So you can write OPB. OPB angle is equal to OBP angle. That's why. Then this one, BOQ angle. BOQ angle is sum of these two angles. OPB angle plus OBP angle. That's 2y. Now we can add these two. This is the first one. This is the second one. Because we need to add these two to get this big angle. So this means these two, and this means we have to add these two angles. So we can write down when you add 1 and 2. When you add 1 and 2, what do you see? AOQ plus QOB angle is AOB angle. That's equal to 2x plus 2y, 2x plus y. I can take 2 out. So 2 times x plus y. X plus y is same as AP B angle. So AOB angle is equal to double of APB angle. Basically, that means the angle subtended at the center is equal to double, twice of the angle subtended on the remaining part of the circle by the same arc. Now we'll look at example number 1. The center of the circle in the given figure is O. Using the information in the figure, find PQR. Whereas PQR is this angle. So what you can do? Now you have to remember the theorem number 1. So this is, if you take RQ as the minor arc, this is the angle subtended on the remaining part of the circle. And this is the angle subtended at the center. So what can you say about QOR angle? That's double of 50, because according to theorem number 1. So theorem number 1 is the reason. Then we found this is 100. This is 15. And also we know this is equal to this because of radii. OQ is same as OR because of radii of the same circle. So if we know this is 100 and put x here because this is an isosceles triangle, you can find x. So we'll do that. 2x plus 100 is equal to 180. Sum of angles in a triangle. Sum of angles in a triangle. So solve this. 2x equals 180 minus 100 means 80. X equals, divide by 2, you get 40. X is 40. So we know this is 40, this is 15, this is 50, and we need this angle, this whole thing, not x. X is the smaller one. So how can we write down the other angle? We can think about OPR triangle. When you take OPR triangle, we can say 50 plus 15 plus 40 plus PQR angle is equal to 180. Sum of angles in a triangle. Then add together, you get 5 here, 4, 5, 5, 10. 105 plus PQR equals 180. So what is PQR? 180 minus 105, you get 75 degrees for the required angle. Exercise 31.2. The center of each of the circle given below is O. Find the values of x based on the given data. So this is the angle subtended at the center, 100. This is the angle subtended on the remaining part of the circle. So what's the relationship? This x is half of this one. Other way around, this is double. So 2x is equal to 100, x equals 100 divided by 2. So straight away we can write 100 divided by 2, that's 50 degrees. Look at the other one. X is now the angle at the center, subtended at the center. This is the angle subtended on the remaining part of the circle. So what's the relationship? X is equal to double of 30. So double of 30 is 60 degrees. Next one. If you take this one, this arc, what is X? Remaining part, the angle subtended on the remaining part of the circle. And this is the angle subtended at the center. So what can you say about X? 2X is equal to 50. So what is X? Divide by 2. 50 divided by 2, you get 25 degrees. Now let's take this one. Now here, this is the minor arc and this is the other arc. So this is the angle subtended on the remaining part of the circle by the major arc. So you need the angle subtended at the center for the major arc. This angle. So what is this angle? 360 minus 50. You get 310. So this is 310. So what is this one? What's the relationship between this and this? This is half of this. So X equals 310 divided by 2. So you get 155. Look at this one. When you take this 80, this is the angle subtended by this arc. So this is the center angle. So what's the relationship? If this is 80, this is 160. But X is other one. So X is with the other arc. So you need this value. So what is this value? 360 minus 160. You get 200. So this is 200. Now we can find out the relationship between X and 200. So you have to divide by 2. X is equal to 200 divided by 2. That's 100 degrees. Next one. Look at carefully. With this arc, this is 70. That's the angle subtended at the center. Now look at carefully. This diagram, O is the center. This is equal to this one. This is an isosceles triangle. This length is equal to this length, radii of the circle. So if this is X, this is also X. Then 70 is the exterior angle. We can write X plus X equals 70. 2X equals 70 means X equals 70 divided by 2. That's 35 degrees. Question number 2. The center of each of the following circles is denoted by O. Providing reasons, find the value of Y based on the given data. So you have to give the reasons as well. So when you take the minor arc PR, this is the angle subtended at the center. This is the angle subtended at on the circumference or on the remaining part of the circle. So what's the relationship? We can write Y is equal to 100 divided by 2. That's 50. According to the theorem number 1. Angle subtended at the center is twice as angle subtended on the remaining part of the remaining part of circle. That's the reason. Look at carefully this one. This arc is here, line is passing through the center. That's the diameter given. And we know all these lengths are not this one. So here, all these three lengths are equal. So if this is y, this is y. Isosceles triangle. So we can write OAC angle is y because of, what's the reason? OAC is an isosceles triangle. Then look at this one. The exterior angle is 90 now. So the sum of opposite interior angles add up to the interior angle. Y plus y equals 90. 2y equals 90. Y is 90 divided by 2. That's 45. So what's the reason? Exterior angle is sum of opposite interior angles. Now look at the next one. It's given ABC. ABC is 70. So this is 70 given. And ACB. ACB is 60. So what can you say about this angle? BAC angle is 180 minus these two, because sum of angles in a triangle is 180. So 70 plus 60. So when you subtract from 180, you get 50 degrees. So this is 50. So here, what's the reason? Angle sum. Sum of angles in a triangle. Now we know this is 50. So what is y? Y is double of that. 50 times 2, you get 100 degrees according to Theorem 1. Next part, y is this one. So here look at carefully. This length is equal to this length, and also it's equal to this one. So you get isosceles triangle. This is 20, this is 20. This is 30, this is 30. So now you can easily find out y. So you have to first write down CBO angle is 20 and ABO angle is 30. Both because of an isosceles triangle. Then we know this angle, ABC angle is 30 plus 20. You get 50 degrees. If this is 50, so what is the y value? Y is double of 50. You get 100 degrees. The reason is theorem number 1. The angle subtended at the center is twice as the angle subtended on the remaining part of the circle. Look at the other one. When you take the major arc PR, so we can find out this angle because this angle is given 110. So POR reflex angle is half of double of 110. 110 times 2. 220. So if that is 220. What's y? Subtract from 360. You get 140 degrees. So y, this is angle at a point. Angle at a point is 360. That's why we subtracted that value by 360. Next one, y is here. We can find out if this is 30, this is 30. Because isosceles triangle. All sides are equal. Now, if this is y, this is y. Then 30 plus y is the angle subtended on the remaining part of the circle. That's equal to half of 110. So half of 110 is 55. So 30 plus y is 55. Y is equal to 55 minus 30. You get 25 degrees. Now look at this question. Here, in this question here, we know this is equal to this one. And also, what can you say about BOC angle? That's double of 70 because of theorem number 1. So this is 140. Now when you connect this one with a line, what's this angle then? These two are equal, so you can find out that angle. We'll put x here. 2x plus 140 is equal to 180, sum of angles in a triangle. Then x equals 180 minus 140, 40 divided by 2. So you get 20 degrees for x. Now think about the whole triangle, ABC triangle. We can write 70 plus, this is y plus 20, and this is also y plus 20. So these two sides are equal. Isosceles triangle, that's equal to 180, sum of angles in a triangle. 70 plus 20, 90, 90 plus 20, 110. So 2y equals 180 minus 110, that's 70 degrees. So y equals 70 divided by 2, you get 35 degrees. Next one, look at carefully the diagram here. This side is equal to this side. We know in this isosceles triangle, this is 50. So if this is 50, this is 50, we can find out this angle because angle sum of a triangle is 180. So we can write QOR angle is 180 minus 100, 50 plus 50. So you get 80 degrees here. Now this is the angle subtended at the center. This is the angle subtended on the remaining part of the circle. So what's the relationship between y and 80? Y is equal to 80 divided by 2. So you get 40 degrees. Next one, when you take the minor arc, this is the angle subtended at the center, and we can find out this angle. BAC angle is 130 divided by 2, 65, because of theorem number 1. If we know this is 65, so this is a straight angle. So y plus 65 is 180 because of straight angle. So y becomes 180 minus 65. You get 115 degrees. Example number 1. The points A, B and C lie on the circle of center O. If ACB, ABC equals AOB, show that AC equals AB. So we'll take a diagram. We'll take a circle. And here O is the center and ABC on the circle. A, B, we take C. ACB ACB, ABC, ABC, when you add it, AOB, this angle. Show that AC equals AB. These two sides are equal. Now we'll see. When you take this triangle, we can say AOB. This angle is twice of ACB angle according to theorem number 1. Here in this question, this is given. Again, AOB is given as ACB plus ABC. It's given. Take this one as first one and this is second one. These two are equal. 1 equals to 2. So we can write 2ACB equals ACB plus ABC. Now, can you see same angle? So I can take this one to this side. 2ACB angle minus ACB angle is equal to ABC. So 2 minus 1 means this is ACB angle. That's equal to ABC. ACB angle is equal to ABC. This one. So what can you say about this triangle? So therefore, ABC is an isosceles triangle because two angles are equal. If corresponding angles are equal, the opposite sides of these corresponding angles are also equal. So we can say AC, opposite to this angle is AC, opposite to this one is AB. So AC is equal to AB. Exercise 31.3. The points AB and C lie on a circle of center O. If OB equals AB, show that ACB is 30. ACB. This one is 30. Now look at carefully. This is given. OB is equal to AB. But we know this is also equal to this one. Radii. OB is equal to OA. That's radii of the same circle. That means AB is equal to OA equals to OB. All sides are equal. So you get an equilateral triangle. Then what is this angle? In an equilateral triangle, one angle is 60 degrees. AOB angle is 60 degrees. If that is 60, we can straight away find out ACB angle is half of 60. That's 30 degrees. Question number 2. PQR and SR points on a circle. Prove that PQR plus PSR is equal to 180. So we'll take this one. So what can you say about PSR angle? PSR angle is half of POR because of theorem number 1. Here I'll put x here, then this is 2x, or I can write 2x here. Then what else I can say? Then what is this angle? This is 180 minus 2x, and this angle I can write down another relationship. So what is PQR angle? PQR angle is this angle is half of POR reflex. Now when you add these two together, so here I'll write with numbers, letters. PSR I took as x. This is x and this is 2x. So you get x here. This one half of POR. So here this one I can write POR. POR reflex angle is 360 minus 2x. So half of 360 minus 2x I can simplify and write 180 minus x. So what's PQR angle? PQR angle is half of that. Now we'll add these two. 1 and this is 2. 1 plus 2, what do you get? 1 plus 2 is PSR angle plus PQR angle is x plus 180 minus x. X get cancelled out. You get 180 degrees. Question number 3. A, B, C and D are points on a circle of center O. If AOC is equal to ABC, these two angles are equal. Show that ADC angle is 60. So ADC angle we have to find out. So what can we write down about ADC angle? I can write down ADC angle is half of AOC angle because according to theorem number 1. Then what can you say about this angle and this one? ABC angle is equal to half of this angle. This is equal to 360 minus AOC angle. I'll put letters. If I take this as x, this is 2x. So what is this one? 360 minus 2x. So when you divide by 2, I'll substitute 360 minus 2x. When take 2 out and divide by 2, you get 180 minus x. That's ABC angle. What is AOC angle? Both are equal. So I can plug this value here. So ADC angle is equal to, that's x value, is equal to half of 100. This value is same as AOC. AOC is same as ABC. So I can write this is half of 180 minus x. That's equal to x. Now solve the equation. Multiply by 2. I get 180 minus x is equal to 2 times x, 2x. Then take minus x to this side. 3x equals 180. Divide by 3. 180 divided by 3. You get 60 degrees. So x is 60 degrees. So x means ADC angle. Question number 4. P, Q and R are points on the circumference of the circle of center O. If OPQ is equal to ORQ, these two angles are equal. We'll put x here and this is x. Show that POR angle, this angle is equal to 4 times ORQ. So 4x. You have to show that this is 4x. So join O and Q. O and Q. Join O and Q. Okay, we'll join these two. So what can you say? If this is x, this is also x. And this is given. So this is also x. So what is this angle? POR angle is twice of this one. So twice of PQR. That means 2 times PQR is 2x. So 2 times 2x is 4x. So 4 times x you can write down in terms of ORQ. So POR is equal to 4 times ORQ. So you have to write down the reason. So here this is twice of this. POR is twice of this is because of theorem number 1. And here why this is 2x? Because of isosceles triangle. You have to write down separately. This is because of isosceles triangle. And then again when you multiply this one you get 4x. Question number 5. The points A, B and C lie on a circle of center O. Show that AOC angle is twice of BAC plus BCA. These two, connection between these two. So we'll first look at carefully what is AOC angle. AOC angle is AOB plus BOC. AOB plus BOC. But what can you say about AOB angle? AOB angle is the angle subtended at the center. That's what's the relationship between ACB angle? So that angle is twice of AB, twice of ACB angle. Twice of this angle is twice of this angle. Then what can you say about these two? BOC angle. BOC angle is twice of this angle, BAC angle. Now look at carefully. We can plug these two, 2 and 3 in equation 1. Take the equation 1 and plug these values. So what is AOC angle? AOC angle is twice of ACB plus twice of BAC. So when you take 2 out from this equation, we get, so BAC angle is there plus BCA. ACB is same as BCA. So AOC is equal to this one. Now we'll try to find out the relationship between the angles in the same segment. What is segment means? Now earlier we discussed about arcs, major arc and minor arc. Now about segment. So when you take the circle, divide by a chord, we call these are segments. So this is called the smaller part, we call minor segment. Big part we call major segment. Look at this diagram. So this part is minor segment, this is major segment. So this angle is in the major segment. So we can write AXB is the angle in the major segment. Then when you take this line AB here, this is major segment. So all these angles, we can say angles in the major segment. So angles in the same segment. So we can write APB, AQB angle and ARB. All are angles in the same segment. Those are in major segment. This one, other way around. So this is minor segment, smaller one, minor segment. So these are angles in the minor segment. So we can say AKB, ALB, AMB. Angles are angles in the minor segment or same segment. So you need to identify what are the angles in the same segment. Now we'll try to find out a relationship. Look at this diagram. So this is AB. When you take this part is this minor segment. This whole big part is the major segment. So what are the angles in the major segment? This angle. Well, we'll try to find out a relationship. This is the angle subtended by the minor arc on the remaining part of the circle. That's equal to half of the angle subtended at the center. So if this is 80, what can you write about AQB angle? 80 divided by 2, that's 40 degrees because of theorem number 1. Now look at this angle. This angle also, the angle subtended on the remaining part of the circle by the minor arc. So same arc. So we can write APB is 80 divided by 2. That's also 40. What about our angle? ARB angle. This is also same thing. This is the angle subtended at the center. Always half of that. So 80 divided by 2. Now what can you say about same segment angles? We got all are same value. So here we see, when you take an example, we see all these same segment angles are equal. So this is your second theorem. So theorem number 2. The angles in the same segment of a circle are equal. So we'll try to prove that. So it says if this is AB is the chord, we'll take this angle and another one somewhere here. This is O, this is P, this is Q. So this is AOB angle. So what first I can write? AQB angle is equal to half of AOB angle because of theorem number 1. Then I can write APB angle. APB angle is half of AOB. Then from this one, 1 and 2, both are equal. 1 equals to 2. So therefore, AQB angle is equal to APB angle. So those are the angles in the same segment. So we can say angles in the same segment of a circle are equal. Example number 1. Find the magnitude of BDC. BDC, this one, using the information in the figure. Look at carefully how we identify same segment angles. So think about, before I do this one, if you take any 2 points on the circle, okay, so here keep your fingers like this, and here if you draw another point angle like this, how can we identify same segment angles? Here look at carefully, it goes here up, down. Here you can go to another direction. Here you can go to the other direction. With same fingers you can do that. 2 fingers. Here goes down. So here this one is one angle, this is another one, this is the other one. So look at carefully and see what are same segment angles. Now look at these 2 points. Here one angle and the other angle is this. So here this and these 2 are equal. Look at the diagram. This is 100 and these 2 lengths are equal. So what can you say about this angle? If this is x, this is also x. So we can write 2x plus 100 is 180. Then what is x? 2x equals 80. 180 minus 100. X equals 80 divided by 2. That's 40 degrees. So this is 40 degrees. So we found this is 40. But we know these two angles are the same segment angles. So we can write BAC is equal to BDC angle. Same segment angles. So if these two are equal, that means what is the value of BDC angle? BDC angle is same as BAC. That's equal to 40 degrees. Exercise 31.4. Find the value of x in the following exercises. Look at carefully this one. So if this is x, this is x. What's the reason? BDC angle is x because same segment angles. If this is x, this is also x. Isosceles triangle because these two sides are equal. So we can form an equation 2x plus, this is given 110. So 2x plus 110 equals 180. 2x equals 180 minus 110. You get 70. So x equals 70 divided by 2. That's 35 degrees. Now look at this one. Same segment angles are equal. So here, when you take this path, if this is 40, this is 40. And this is 30. But here, you can get a triangle, so you can find x. 30 plus 40 plus x equals 180. 70 plus x equals 180. So what's the x value? 180 minus 70. So 110. Next one. AB equals AC. AB equals AC. These two lengths are equal. Given. So, if this is 50, this whole thing is 50. Then, look at carefully, this is same segment angles. This is x, then this is also x. So, what is x? Look at this ABC triangle. X plus 50 is 180. Sum of angles in a triangle. X plus 100 equals 180. So what is x? 180 minus 100. You get 80 degrees. This one. These lengths are equal. When you take BC arc, mine arc, this is the angle. No, you have not given the center. So this is not the angle at the center. So we have to look at another way. But we know if this is x, this is x. Same segment angles. Then if this is x, this is also x. Here these two lengths are equal. Now we can see x and x becomes 110, x plus x, because the exterior angles add up to other sum of opposite interior angles. Now we can form an equation. X plus x equals 110. 2x equals 110. x equals 110 divided by 2, that's equal to 55. This question, look at carefully. When you take this way, these two angles are equal, same segment angles. This is 70. Then look at carefully. If this is 70, this is 70. Isosceles triangle. So what is x? X is sum of 70 and 70. So x is equal to 70 plus 70, that's 140. So you can write down because of exterior angle. Next one, x is the full thing. If this is 70, this is also 70. Look at ABC triangle. This length is equal to this length. So isosceles triangle. So you get this one is 70. Now you can find out x. When you take ABC triangle, 70 plus 70 plus x equals 180. 140 plus x equals 180. So what is x? 180 minus 140. You get 40 degrees. This question, if this is 120, what is this angle? 180 minus 120, that's 60. That's CBP angle. This is 60. So same segment angles are equal. So this is 60 again. CED angle is 60. Same segment angles. Theorem number 2. If this is 60, what is x? Sum of x and 60 is equal to 180. Straight angle. Then x equals 180 minus 60. You get 120. This one, this angle is 50. So this is 50. Same segment angles are equal. So if this is 50, what is x? 180 minus 50. So we can write BAC angle is 50 because of same segment angles. Then if this is 50, you can write x plus 50 is equal to 180 because of a straight angle. Then what is x? 180 minus 50, you get 130 degrees. Now look at this one. Here, this is 70 given. What can you say about this angle? BAP angle. This is also 70. Same segment angles are equal. Now x is given the whole thing. So what can you say about x? X is equal to 70 plus 30. What's the reason? Exterior angle is equal to sum of interior angles. So the value x is 100. Example number 1. Prove that AC is equal to BD using the information in the figure. AC is equal to BD. Now look at carefully. Here these two lines are parallel. So we can say this angle is equal to this angle. Alternate angles. So here we'll write ABD angle is same as BDC angle. And other way around. This angle is equal to this angle. BAC angle is equal to ACD angle because of alternate angles. But can you say if you take these two angles are equal? Because same segment angles are equal. We can write ABD angle is equal to ACD angle. Same segment angles are equal. Now, if we want to show that AC equals BD, this length is equal to this length, we have to show that this length is equal to this length is equal to this length. So, how can we show that? We know, so this is equal to this one. So, if this is x, this is x. But this is x, this is also x because of alternate angles. So, from this, we can say AXB triangle is an isosceles triangle because these two angles are equal. So, if these two are equal, we can say AX is equal to XB. Then when you take the small one, this is equal to X as well as this is also equal to X because of same segment angles. So when you take XDC triangle is also an isosceles triangle. So I can write, I'll write XC first. XC in this triangle, XC is equal to XD. So this is 1, this is 2. So when you add 1 and 2, what you get? AX plus XC is equal to XB plus XD. Or BX plus XD. So, I get, when you add these two together, I get AX plus XC. AX plus XC is AC. BX plus XD becomes BD. So, you get AC is equal to BD. Exercise 31.5. If AB is parallel to DC, now here you have to show ADC angle is equal to BCD angle. We'll take this one. If I take this one as A, ADB angle is same as this angle, ACB angle, because same segment angles. Then if I take BDC angle, this angle is same as this angle. Same segment angles. BAC angle, that's also same segment angles. But I know these two are parallel. So if this is B, This is also B. So I can write instead of BAC, BAC angle is same as ACD angle. These two, because of alternate angles. Now, if I add this and this and replace with this one, what can I say? ADB angle, ADB plus BDC. 1 plus 2. I'm getting ACB plus BAC, but instead of BAC, I can write ACD. BAC, I can write ACD. So instead of that, I can write ACD. So what is ACB, ACB and ACD? I am getting BCD angle. So this side I am getting BCD angle. What about this side? ADB plus BDC, I get ADC angle. So these two are equal. Question number 2. If PX is equal to XQ or QX, show that PQ is parallel to SR. Okay, so here when you take this segment, so these two angles are equal. If this is A, this is A. I can write QPR angle is same as QSR angle. Same segment angles. Then if I take this triangle, isosceles triangle, these two are equal. This is also A. So PQS angle is equal to, these all are A angle. This is also A because of isosceles triangle. Isosceles triangle. Now, this is equal to this because of same segment angle. So, I can write PQS angle is same as PRS angle, same segment angles. Now, what can you say about? We see these two are the same. So, therefore, QPR angle is same as PRS angle. From these two, we can write down this. So, that means these are alternate angles. Alternate angles are equal. Alternate angles are equal means the two lines are parallel. So PQ, therefore PQ is parallel to SR. Question number 3. If AD is parallel to BC, these two lines, show that AX is equal to DX. These two. Now look at the diagram. If these two are parallel, if this is A, this is A. So you can write ADB angle is same as DBC angle, that's A. And also this angle, DBC angle is same as this angle, DAC angle. What's the reason? So this is alternate angles. And this is same segment angle. Now what can you say about this? So therefore, ADC angle, this one. So can you see these two are equal? When you take AXD triangle, what can you say? A angle is equal to D angle. So that's an isosceles triangle. Therefore, AX should be equal to XD because these two sides should be equal. AX should be equal to DX because of isosceles triangle. Question number 4. Show that AXC angle is equal to AYB. Now we'll take a letter here. What is, if we put A here, BXC angle is same as BYC angle because same segment angles are equal. Same segment angles are equal. Then if these two are equal, then subtract from 180 both angles. BXC 180 minus BYC. I'm subtracting from 180. So what am I getting? 180 minus this is same as AX. C 180 minus BXC is AXC. 180 minus BYC is same as AYB. So we can see these two are equal. Question number 5. If BPQ angle is equal to BRQ angle, this angle, show that BE is the bisector of AEC. That means we have to show that these two angles are equal. That's the proof. Now how can we do that? We'll take letters. Now we can see when you take same segment angles are equal. So this is, if we put A, this is A. And this is also A. Same segment angles are equal. Then if this is B, this is also B because of the given information. And this is also B. So what is this angle? This angle is 180 minus A plus B. Then when you take this whole triangle, this is A, this is B. What is this angle? 180 minus A plus B. So you get same angle. So this is the bisector. So we'll write down. First you have to write down these angles. EAD angle is same as EBD angle is same as ECD angle is equal to A. Same segment angles. Then you have given BPQ angle is same as BRQ angle. We put B letter, that's given. And this is also equal to, you can write down, this is given. First you write down, this is given. And we can write down BPQ is same as APE angle. Opposite angles are equal. And also we can say, here first I'll write down, this is opposite angles are equal. Now you can say, when you consider APE triangle, what is AEB angle? AEB angle is 180 minus A plus B. Add these two and subtract from 180, that's 1. Then when you take BER triangle, we can say BEC angle is also 180 minus A plus B. So that's second. From 1 and 2, both are equal. So therefore, we can say AEB angle is equal to BEC angle. So these two are equal, means bisected. So therefore, we can write down, therefore BE is the bisector of AEC angle. Question number 6. If AB equals AC, these two lengths are equal, show that CDX, this angle is double of, twice of ABC. So you have to show that double of this. Okay. So we'll first take, if this is A, these two lengths are equal, this is A, isosceles triangle. Then if you take this one, so here if you take these 2 points, so this angle, if this is X, this is also X. Same segment angles are equal. Then what about this angle? This angle becomes A minus X. This is A minus X. This is A and X. When you add it together, you get this angle. So what is that? A minus X plus A plus X. Minus X plus X get cancelled out. You get 2A. So this becomes 2A. So we get double of this one. So we'll have to write down all steps. ABC angle is same as ACB angle, that's A. Isosceles triangle. Then ABD D angle is same as ACD angle. That's X. Same segment angles. Then what about DBC angle? DBC angle is A minus X. Then what is BCD angle? BCD angle is A plus X. When you add these two, 1 plus 2, you get CDX angle. CDX angle is equal to A minus X plus A plus X. X get cancelled out, you get 2A. So 2 times A, instead of A I can write ABC. So CDX is equal to 2 times ABC. Question number 7. If XB is equal to XC, these two lengths are given equal, show that AC is equal to BD. So we'll take ACX triangle and BDX triangle. We know that this angle is equal to this angle. Why? What's the reason? Same segment angles are equal. So I can write CAX angle is same as BDX angle. That's A. Same segment angles are equal. And this angle is common for both triangles. AXD angle is common. And also it's given, if you take this triangle, CX is equal to BX. That's given. So when you look at these three, 2 angles and 1 length. So these 2 triangles are congruent. So if the 2 triangles are congruent, corresponding elements are also equal. So opposite to this one is AC. Opposite to this one for this triangle is BD. So AC should be equal to BD because of corresponding elements are equal. Here, what's the reason these two are congruent? Angle, angle, side. 2 angles and 1 side equal. Question number 8. If XS is equal to XR, these two lengths are equal, show that XP is equal to XQ. XP is equal to, so we have to show that these two are equal. Now we'll do using angles. If these two are equal, these two are equal. Then if this is A, this is also A. Same segment angles are equal. And if you take other way around, this should be A. Now when you take this triangle, these two are equal. Then PX or XP should be equal to XQ. So that's what you have to find. So we'll do that. So we can write XSR is equal to XRS angle. That's A because of isosceles triangle. But we know SRX or XRS is same as PQX angle. This one. Same segment angles are equal. Then from these two we can say XSR is equal to PQX. These two are equal. Therefore, PQS is an isosceles triangle. So if these two are isosceles, if the triangle is isosceles triangle, we can say corresponding sides are equal. PX is equal to XQ. So I can write XP as well. So XP is equal to XQ. Now we'll look at the relationship between angles in a semicircle. What is semicircle means? When you divide the circle into two equal parts. So that means this is the diameter. So we call equally divided semicircle. So one part. So this part we call semicircle. Now we are trying to find out the angles in the semicircle. So this is the angle in the semicircle here. This is the angle in the other semicircle. So here, what are the angles here? We can identify AQB angle and APB. APB angles are angles in a semicircle. Now we'll see if this is the diameter, this is a straight line. So what is this angle? 180. So that's the angle subtended at the center. If you take this AB arc, this is the angle subtended at the center. Then what about this one? This is the angle subtended on the other side of the circle, remaining part of the circle. So what's the relationship? We found out according to theorem number 1, this is half of that. So if this is 180, what should be this angle? 180 divided by 2, that's 90 degrees. So that's a theorem. So we are now taking this one as 90 degrees. Angles in a semicircle is always 90 degrees. So we'll take that theorem now. That's theorem number 3. An angle in a semicircle is a right angle. That means 90 degrees. So take a diameter, and this is AB, and this is, we'll take P, and here you have to take AOB angle. So how can we prove that? What is AOB angle? Is equal to 180 because it's a straight angle. But we know AOB is double of APB angle. What's the theorem? Theorem number 1. Theorem number 1 says angle subtended at the center is equal to twice the angle subtended on the remaining part of the circle. So according to this one, 1 and 2, what can you say about these two? 1 and 2, both are equal. You can say 180 equals 2 APB. So what is APB? 180 divided by 2. So that's 90 degrees. So always angle in a semicircle is 90 degrees. Example number 1. PQ is a diameter of the circle PQRS. PQ is the diameter of the circle PQRS. If QPR, this is given 20 and PS equals QR. PS is equal to QR. Find the magnitude of RPS. That means this should be angle. RPS angle. RPS angle. So we need this angle. So this is a semicircle. So what can you say about this angle? This is 90 degrees and this is also 90 degrees. So first thing you can write down PSQ is same as PRQ. That's 90 degrees according to Theorem 3. Angle in a semicircle. Angle in a semicircle. Is 90 degrees. Then if we know this is 20. So what is this angle? This angle is 90 minus 20, that's 70. Then if this is 70, how can we find out this angle? Now we'll take PRQ triangle and PSQ triangle. What can you say about these triangles? We know PS equals RQ. That's given. These two lengths are equal. And this is a right angle triangle. So you get PRQ. We found out this is 90 degrees. So you don't need to write it again. And also PQ is common length. So what can you say about these three? This is a right angle triangle and this is the hypotenuse and one side equal. So therefore, these two triangles are PRQ triangle is congruent to PSQ triangle. What's the situation? Right angle triangle, hypotenuse side, RHS. So we found out these two are equal. That means this angle, if you take with another color, opposite to this side is this angle is equal to opposite to this one. So this angle. So these are equal. So therefore, I'll put this is x. So x plus 20 is equal to 70 degrees. X plus 20 is 70 degrees. So what is x? X equals 70 minus 20. So 70 minus 20 is 50 degrees. So x is the angle RPS. So that's the angle we want, RPS angle. So that's 50 degrees. Exercise 31.6. The center of each of the following circles is denoted by O. Find the value of x based on the data in the figure. So we can see this is the diameter and this is 90. According to theorem number 3, angle in a semicircle is 90 degrees. If this is 90, what can you say about this triangle? 30 plus 90 plus x is 180. Angle sum of a triangle is 180. So 90 plus 30 is 120 plus x is 180. So x equals 180 minus 120. That's 60 degrees. This one again, semicircle. Semicircle means this is 90 degree angle in a semicircle, and also these two sides are equal means this is x. Isosceles triangle. Now, angle sum x plus 90 is 180. Angle sum of a triangle is 180. 2x plus 90 is 180. So 2x equals 180 minus 90 means 90. What is x? 90 divided by 2, you get 45 degrees. Look at this one. This is also diameter. So this angle is 90 degrees. If this is 90, what is this one? What is this angle? We'll put x here. X plus 60 plus 90 equals 180. So x plus 150 equals 180. So what is x? 180 minus 150. That's 30 degrees. Now look at carefully this big triangle. If this is x, this is also x. Here I need to use different letters because x is already there. So we'll take a different letter. I'll take all y's. This is y. So I found y, not x. Now this is y, this is also y because of isosceles triangle. Now I can find out x. Here this is 90, this is 90. When you take this triangle, 90 plus x plus y equals 180. Now plug the y value. Y we found out 30. 120 plus x equals 180. So what is x? 180 minus 120. That's equal to 60. So x equals 60 degrees. Question number 4. Look at carefully. If this is x, this is also x. Same segment angles are equal. Then this is the diameter passing through the center. So this angle is 90 degrees. Angle in a semicircle. Now you can think about this triangle ADB. X plus 50 plus 90 equals 180. X plus 140 equals 180. So what is x? 180 minus 140. You get 40 degrees. Look at this one. This whole thing is given x. So this is a diameter. This is 90. This is 90. Angles in a semicircle is equal to 90 degrees. Now you can use the sum of angles in a quadrilateral. Sum of angles in a quadrilateral. X plus 90 plus 90 plus 110 is equal to, what's the sum of angles in a quadrilateral? 360. 60. So x plus, you get 180, 180 and 110, you get 290 is equal to 360. So x equals 360 minus 290. So you get 70 degrees as x. Example number 1. PQ is a diameter of the circle PQRS. The chord RS, this one, has been produced to X. Prove that RPQ plus PSX PSX is this one. When you add these two, that's 90 degrees. So what's the first step we can think of? Can you see this is a diameter now? So this angle is 90 degrees and also this angle is 90 degrees. So we have to first write down PSQ angle is equal to PRQ angle is equal to 90 degrees. Angles in a semicircle is right angle. That's 90 degrees. Then if this is A, this is also A. Same segment angles are equal. And if this is B, this is equal to B. Same segment angles are equal. Then what can we say? If you take this line, 90 plus. So how can you find out this angle? This plus this is 180. And how can we find out this angle? This is B. So when you add those two, we'll see whether we are getting 90 degrees. So we can write down, the next step is we can write down SQP angle is same as SRP angle, that's A. And RSQ angle is same as QPR angle, that's B. Same segment angles. Theorem number 1. Now, how can we find out SP or PSX? PSX is equal to, or PSX plus 90 plus B value is equal to 180. So what is PSX? Subtract, you get 180 minus 90 minus B. So you get 90 minus B. That's first one. So what is RPQ angle? RPQ angle, that's B. We found that same segment angles are equal. When you add these two, 1 and 2, what you get? 1 plus 2, you get RPQ plus PSX angle is 90 minus B plus B. B get cancelled out. You are getting 90 degrees. Example number 2. The centers of the given two circles are X and Y. These are the two centers. prove that AEB angle is equal to CED. CED angle. These two are equal. So here, when you take this circle, what is this angle? This is 90. When you take this circle, this is 90. So can you see? When you subtract the middle angle, you get the same value. So we'll first write down AEC angle, not B. AEC angle is 90 degrees. That's equal to BED angle. BED angle, because angle in a semicircle. Then we can subtract BEC angle from both sides. One minus 2, what you get? BED angle minus BEC angle. BED angle minus BEC angle, you get CED angle. CED angle. Then other side, AEC angle minus BEC angle. What you get? AEC angle minus BEC angle. You get AEB angle. So that's what we need to prove. AEB angle is equal to CED angle. Exercise 31.7. AC is a diameter of the circle ABCD. Show that BAD, this angle plus BCD angle is 180. We know that if this is the diameter, this is 90, this is 90. Then we can write down the sum of angles in a quadrilateral is 360, and you can find out the other two. So first you can write ADC angle is same as ABC angle, that's 90 degrees. Angles in a semicircle. Then if you take the quadrilateral ABCD quadrilateral, we know that sum of angles in a quadrilateral add up to 360. So I can write BAD plus BCD plus 90 is equal to 360. Sum of angles in a quadrilateral. Then these two becomes 180. When you subtract 180 from 360, what you get? You get 180. So we get BAD plus BCD is equal to 180. Question number 2. PR is a diameter of the circle PQRS. If PQ is equal to SR or RS, show that PQR is a rectangle. So here opposite side. If it's a rectangle, opposite sides are equal. So we need to show that this side is equal to this side. But we know this is the diameter, this is 90 degrees. So we can take PSR triangle and PQR triangle. So PSR is equal to PQR, that's 90 degrees because of angles in a semicircle. And PR is common. And PQ is equal to SR. That's given. So when you look at this is right angle triangle, hypotenuse and one side equal. So these two are congruent. PSR triangle is congruent to PQR triangle. What's the situation? Right angle triangle, hypotenuse side. So therefore, what can you say about the corresponding elements? Corresponding elements are equal. So here we can say opposite to this one and opposite to this one. These two lengths are equal. So RQ is equal to PS, and also we can see this is 90, this is 90. So these also we can prove that from the congruent, this is equal, this one is equal to this one, and here alternate angles equal means parallel as well. Opposite sides parallel, and also this is 90 degrees. So when you take this one, this length, this angle is equal to this angle. Opposite to this one is this angle, and also when you take this one, this angle is equal to this angle. So you can prove that this is also 90 and 90, because when you take this one, the triangle 90 plus this is equal to 180. So this one plus this one is 90 degrees. So you can prove that. We'll write down that also. When you take, I'll take this is A, this is B. We can show that this is B and this is A. B plus A plus 90 degrees is equal to 180. So A plus B is also 90 degrees. So each angle A plus B is 90 and opposite sides are equal. So therefore, PQRS is a rectangle. Question number 3. PQ is a diameter of the circle PQR if PQ equals QX and PR is equal to RQ is equal to RX. Show that PXQ is 90 degrees. Now PQ is the diameter. So this is 90 degrees. If this is A, this is A. Why? This is isosceles triangle. And what else we can say? This is 90. And here, this side is equal to this side. So if this is A, this is A. So we have to show that A equals 90 degrees. So when you take This one A. Here, look at this triangle. This is A. This is also A. Now we can write down a formula for all these. First, we'll write down PRQ is 90 degrees. Angle in a semicircle. Then RPQ is equal to PQR is equal to A isosceles triangle. Then again we can write down, if you take PXQ triangle, the big triangle, QPX angle is same as PXQ angle. That's also A because of these two sides are equal, isosceles triangle. Then when you take the big triangle, we can write down A plus A plus A plus A. You get 4 A's is equal to 180. That's angle sum of a triangle. Now 4A equals 180. What's A? 180 divided by 4. So this is equal to 45. Now what's the angle we want? PQX. PQX is what? PQX. So this angle is PQX. That's 2A. 2 times A. So 2 times 45, you get 90 degrees. Question number 4. AC is the diameter. That means passes through the center. And of the circle ABCD, if BC is parallel to AD, show that ABCD is a rectangle. How can we show that? If these two are parallel, this angle is equal to this angle. Alternate angles are equal. And we know this is 90 and this is 90. Same angles in a semicircle. Now when you take these two triangles, these are congruent. The hypotenuse is the same and two angles. One side and two angles are the same. So you can see these two are congruent, then this length is equal to this length. Opposite corresponding elements are equal. So we'll use that method. So first thing you can write, ABC angle is same as ADC angle, that's 90 degrees. Angle in a semicircle. Then you can write down BCA angle is same as CAD angle. We put A, that's alternate angles because the two sides are parallel. And if we take this ABC triangle and ACD triangle, we can see AC is common. So two angles and one side equal. So therefore ABC triangle is congruent to ACD triangle because of angle, side. So angle, side. Then you can say corresponding elements are equal. Opposite to A angle is AB. Opposite to A angle is CD. So AB is equal to CD as well as BC is equal to AD and parallel as well. So opposite sides are equal and one pair is parallel. And also here we can say these two angles also 90 degrees. And how can we show that this is also 90? This is equal to, this one is equal to this angle because of corresponding elements. So we can write down this A plus this angle is also 90 degrees. So all angles 90 degrees and the opposite sides are equal. So therefore this is a rectangle. So we have to write down the angles also. I can write down ACD angle is same as BAC angle, these two. Then if I take A plus X, this triangle, I can write A plus, I'll put X as the other angle. A plus X plus 90 is 180. So A plus X equals 180 minus 90. So that means all angles are, A plus X means this angle, all 90 degrees and opposite sides are equal. So therefore ABCD is a rectangle. Opposite sides are equal and angles are 90 degrees. Question number 5. PSQ is a diameter of the larger circle and SQ is a diameter of the smaller circle. If RQ intersects the smaller circle at X, show that PRS angle is equal to RSX, this angle. So look at carefully. If we can show that these two lines are parallel, that means alternate angles are equal. So we'll see whether we can show that these are parallel. Now look at carefully the big circle. This one is 90. And also when you take the smaller one, this is 90. So PRQ angle is equal to SXQ angle, that's 90. Angle in a semicircle. Then look at carefully. These are the corresponding angles to PR and SX lines. So that's equal to, so you can write down those are corresponding angles. So corresponding angles are equal. Corresponding angles are equal. That means PR parallel to SX. Now we found out PR is parallel to PX. So therefore PRS angle is same as RSX because these are alternate angles. Question number 6. PR is a diameter of the circle PQRS if SRP is equal to QRP. These two are equal. Show that SPR, this one is equal to QPR. These two. Okay, so we'll put this one A and this is also A because it's given. First we'll write down P, not P, SRP. SRP angle is equal to QRP. That's given. And this is a diameter, so this is 90, this is 90. So we can write down PSR angle is equal to PQR angle, that's 90. Angle in a semicircle. Then what can you say about when you add these two together and subtract, what can you say about PRPQ angle? RPQ angle is 180 minus the sum of these two angles, 90 plus A. So when you simplify, you get 90 minus A. That's your first one. When you take the other triangle, what's SPR angle? SPR also 180 minus 90 plus A. When you simplify, you get 90 minus A. So this is your second equation. Look at 1 and 2. 1 is equal to 2. So therefore, we can write SPR angle is same as QPR. Question number 7. The two circles in the figure intersect at P and Q. PX and PY are diameters. PX and PY are diameters of the two circles. Show that XQY is a straight line. XQY is a straight line means we have to show that this is add up to 180. These two angles add up to 180. When you take this one, this is the diameter. So what is this angle? PQX angle is 90 degrees because of angles in a semicircle. Then when you take this one, what is this angle? This is also 90. PQY is 90 degrees. Angle in a semicircle. When you add these two, 1 and 2, you get PQX plus PQY. PQX plus PQY is equal to 90 plus 90, that's 180. So these two add up to 180 means that's a straight line. So this is a straight angle. So therefore XQY is a straight line. Miscellaneous exercise. Mark the given data on the given figures and solve the problems. The center of the circle ABC is O. If ABO is equal to OBC and ABO is 40 degrees, find the magnitude of ACO. ACO means we have to find out this one. We'll put X here. We need to find out X. If this is 40, this is 40. It's given. And we know these two are radii. This is equal to this. So if this is 40, this is 40. Then we know this angle. What's this angle? 180 is equal to 40 plus 40, 40 plus 40 plus, we'll take y. So what's the y value? Y is 180 minus 80, that's 100 degrees. So this is 100. Then what happens to this angle? So BAC angle becomes half of that. So 100 divided by 2, that's 50 degrees because of theorem number 1. Now look at the big triangle ABC. 50 plus 40 plus 40 plus 40 plus x is 180. Sum of angles in a triangle. So add all together 90, 130, 170. 170 plus x equals 180. So what's x? 180 minus 170. You get 10 degrees. Question number 2. BD is a diameter of the circle ABCD. BC equals CD. BC equals CD. And ACB. ACB is 35. Find the magnitude of ABC. ABC. So we need this angle. We'll put this one as x. We'll put this one, we want x. And this one as y. If we put this one as y, what's this angle? This is y, because same segment angles are equal. If this is y, this is y. So you can find out a relationship between this and this, x and y. So when you take the bigger triangle, I can write x plus y plus 35 is equal to 180. This angle plus this angle plus this is 180. So what is x plus y? 180 minus 35. So you get 145 for x plus y. But we need to find out y. This is the diameter. Here, this is the diameter. So what is this angle? This is 90 degrees. So we can find out what is the value of y. So 90 degrees. So y plus 90 is 180. So what is 2y equals 180 minus 90 is 90. Y equals 45 degrees. So 45, plug it here. x plus 45 is 145. X is 145 minus 45. You get 100 degrees. Question number 3. The center of the circle ABCD is O. If BC is parallel to DO or OD and ABC is 60 degrees. Find the magnitude of the angle BCD. BCD means this angle we need to find out. How can we find out? Look at carefully. If this is 60, this is 60. And because why this is 60? Corresponding angles are equal. Now look at carefully here. If you take this one, BD as the arc, this is the angle. If you take the major arc, this is the angle subtended on the other side of the remaining part of the circle is this angle. What about the angle subtended at the center? We can find out that's this angle. So what is that angle? This is 60, this is 180. 180 plus 60, you get 240 degrees, the angle subtended at the center. So that's the reflex angle, DOB angle. So that's DOB reflex angle. Now if this is 100, 240, what is this angle? DCB angle is half of that. 240 divided by 2, you get 120. What's the reason? Theorem number 1. So you want BCD angle. So BCD angle, or this is DCB, same thing, that's equal to 120 degrees. Question number 4. The center of the circle ABC is O. AC has been produced to X such that BC is equal to CX. Show that AOB is equal to 4 times CBX. CBX. So we'll take this one as X. So you have to show that this is 4 times X, 4X. So if this is X, this is X. Then what is this one? This becomes X plus X, 2X. Exterior angle. If this is 2X, you get double of that. You get 4X. So you can prove that. So we'll write down CXB is equal to CBX. That's equal to X angle because of isosceles triangle. Then you can write down ACB angle. ACB angle is X plus X, that's equal to 2X because of exterior angle. Then you can write down AOB angle is double of ACB angle because of theorem number 1. Then 2 times ACB is same as 2X. 2 times 2X is 4X. Now instead of x, I can write down CBX, because CBX is same as x. CBX is 4 times CBX is equal to AOB. Question number 5. The points A, B, C and D lie on the circle such that AD equals BC. Show that DB, this length, is equal to CA, this full length. So we'll take this point as O and consider AOD triangle and BOC triangle. It's given AD equals BC. That's already given. And here this angle is equal to this angle. Alternate, the opposite angles are equal. DOA angle is equal to COB angle, opposite angles. And also, when you take this angle and this angle, both are equal, same segment angles. ADB angle is same as ACB angle, same segment angles are equal. Now, what can you say about these two triangles? Those are congruent, angle, angle, side. Therefore, AOD triangle is congruent to BOC triangle, that's angle, angle, side. Now, what can you say about the corresponding elements? AO is equal to OB, as well as OD. OD is equal to OC. Now, when you add these two, what you get? 1 plus 2. What you get? 1 plus 2. You are getting AO plus OC, OB plus OD. Now, we'll look at the diagram and see. AO plus OC. What's that? AC. OB plus OD. That's BD. So, or DB. So, we can straight away write down. Therefore, AO plus OC is AC. OB plus OD is DB. So, these two lengths are equal. Question number 6. PQ is a diameter of the circle with center O. Also, QR is parallel to QR. QR is parallel to OS. Show that SR is equal to SP. SR is equal to SP. So, these two lengths are equal. So, that means if we can show that these two angles are equal, we can do that. So, we'll see from this diagram, we can write PRQ angle is 90 because of angle in a semicircle. Then what else? These two lines are parallel. So that means if this is 90, this is 90. So P, I'll put X or something, that is 90 degrees. And also what else we can see? Corresponding angles are equal. So when you take this arc, SP arc, what can you say about this and this angle? This is the angle subtended at the center. This is angle subtended on the remaining part of the circle. So if this is x, what can you say about this angle? This is 2x. So first I can write down SRP is x, then POS angle is 2x because of theorem number 1. And if this is 2x, this is 2x as well. So what's the theorem? What's the rule there? Corresponding angles, because the two lines are parallel. So we can write POS angle is same as PQR angle, that's 2x, because of corresponding angles. Now look at carefully, and what is this angle then? This is 90, this is 90, so that means these all 90 degrees, because here also corresponding angles. So we'll write that down. If this point is x, we'll take PQR is t, this point is t. So PTO angle is 90 because of corresponding angles. Now when you take SPO triangle, we know that OS is equal to OP, radii of the same circle. Those are equal. So this is equal to this. So that means this angle is equal to this angle. So we'll put y or something. This is y and this is y. So we can say what is y? 2y plus 2x is equal to 180. So 2y equals 180 minus 2x. So y equals, divide all these by 2, you get 90 minus x. So this angle you found 90 minus x. This is 90 minus x, this is 90. So what is this angle? You get this is x. So we can write down PSO angle is 90 minus x. That's y angle 90 minus x. So when you take SPT triangle, we can say this angle SP, that's the other side, SPR angle is equal to PSO, that's equal to, these angles are both x. This angle and this angle equals x. So this is an isosceles triangle. So therefore it's an isosceles triangle. So what can you say about isosceles triangle? In isosceles triangle, lengths are equal. So therefore we can write down PS is equal to SR, because these two lengths are equal. In this lesson, we discussed about angles in a circle, and we discussed three important theorems. What are the theorems? Angles in a semicircle is 90 degrees, angles in the same segment are equal, and angle subtended at the center is twice as the angle subtended on the remaining part of the circle. So remember those three theorems and apply in exercises.